Okay, Bismillahirrahmanirrahim. Okay, folks, welcome back. We are looking at this 2012 June paper 1 page. Okay, we get back to we left off last week on question number 20. We are live, we're recording. We're looking at the solve this simultaneous equations. Okay, let me get myself a pen. Got a red pen. Let's go for a green pen. Okay, right. Now, the idea behind simultaneous equations is that we eliminate either the x or the y first, okay? And we eliminate them by making the coefficients either equal or opposite. Now, if you look over here, we have plus 2 and minus 3. So if I choose this one here, if I choose to eliminate the y's, I've got to make the plus 2 and minus 3 opposite. How do we do that? We multiply the top number by 3 and the bottom number by 2. That's one way we could do it. So that will give us what? So multiply everything on the top by 3. So we have 5x plus 2y equals 11 times that by 3. That will give us what? Let's just do over here. That will give us 15x. Folks, if you spot a mistake, can you politely point it out straight away? 3 times by 2y is 6y. And 3 times by 11 is 33. That's the new first equation. Second one, times that by 2. 4x becomes 8x. Minus 3y becomes plus 6. Minus 6y. And 18 times by 2 will give us? 18 times by 2 will give us? And 18 times by 2 will give us? Okay, I've written on the board on actually 3 times and nobody's paying attention. Okay, folks, can we please pay attention? Right. Now, in order to eliminate the y coefficients, we have a plus 6 and a minus 6. How do we eliminate opposite coefficients? Remember, plus 6 is opposite of minus 6. How do we eliminate now that we have that good situation with the opposite? What do we do? Do we add them, equation, or do we minus them? If you have two opposite things, you don't minus them. You add them to eliminate them. Yeah? So 15x add 8x will give us 23x. Now plus 6y add minus 6y will give us 0y. And that's what we wanted to do, to eliminate the y's. So the y's have become nothing. We don't write anything down there. Then we have 33 plus 36, that will give us 69. Now, have we achieved our first goal to eliminate either x or y? We have. The y coefficient has gone down to 0, so y is gone. So we're left with 23x is equal to 69. Now we need to work out the value of x. So the opposite of time by 23, don't waste times here. Opposite time by 23 is? Divide by 23. So x is equal to 69 divided by 23, which gives us an answer of 3. Beautiful. Do you understand that now, yeah? So x is equal to 3. Now that we worked out the value of x, we can substitute it back in and work out the corresponding value of y. Okay, let's do that. So now we have 1, 2, 3, 4 equations, and you can put x equals 3 into any of those equations, but we put into the easiest one. So Mr. Honey, which one would you like me to put in, considering that you want to choose the easiest one? Okay, right. So we have, which one should we choose, Mr. Honey?
The first one.
The first one, lovely. Okay, let's get rid of the red and let's go for the blue. So we have here 5x add 2y is equal to 11. Let's grab that 3 from here and put it straight into there. Okay, let's see what we get. Are you with us, Harun? Okay, 5 times by 3 plus 2y is equal to 11. Okay, Mr. Harun, I'm just going to pause this. Right, okay, 5 times by 3 will give us 15. 15 add 2y is equal to 11. I want to work out the value of y. Okay, folks, is everything okay? We now have made a mistake, have we? You alright for the moment? If you spot anything going wrong, please tell me straight away, so I don't want to be spending hours editing videos. So the opposite of add 15 is?
Minus 15.
Minus 15. 11 minus 15 is?
Minus 4.
So we have plus 2y. Now, What do you do next? Okay. And the opposite of multiplying by plus 2 is
Divide.
dividing by 2. So y is equal to minus 4 divided by 2, which gives us an answer of
-2.
minus 2. That's my second answer. So if I want to summarize it here, x is equal to 3 and y is equal to minus 2. Put your hand up if you got the answer for homework. Okay, well done. If you haven't got the answer for homework, fill it in now as a correction. Have you got that now? You happy with that? That's a nice straightforward sometimes. They can't put quadratics in there and make it quite a big deal out of it. But that's a nice, that kind of question in the exam is a gift. That's like they're being nice to you. Okay, let's move on. Okay, let's move on a bit here. Okay, right, here's our question. Right, is there any part of that? Okay. B, C, and D. So diagram not accurately drawn. Can somebody tell me what is the significance of this word here? Diagram not accurately drawn. What do they mean by that? They want you not to
Measure.
start measuring them with your protractor, for example. Okay. I feel like we okay. Ifra, what are we doing at the moment? That's the paper. Have you got all the stuff right?
Yeah.
Are you sure? Okay, as I'm going through the answer, make sure you check off your answers as well, yeah? So don't worry about rushing into that work yet. Okay, B, C, and D are points on the circumference of a circle center 0. A, B, and AD are tangents to the circle. This one and that one. This angle is 50. Work out the size of the angle BCD. Let's get color. They want us to work out BCD, which is here. Now, BCD, angle BCD, this one, B, C, and D, that is connected to which angle? That one, BOD. So, we know, it's a little note over here, we know that BCD, what's the connection between BCD and BOD? BOD?
B
What's-
and D are 90.
So, BCD is half of,
Oh.
okay, BCD is equal to BOD divided by 2, angle BOD. So once we know this angle here, we can very easily work out the angle they want us to work out. Okay, are we happy with that, everybody in the class? Okay, I need to see some of your faces. All I can see is some of your heads looking at. So, to work this one out, we need to work out this one. Right. Let's start doing some maths. Now, what do we know about this angle here? This is a tangent. When the tangent meets a radius, it always meets at,
90.
and this one always meets at
90.
90. Now, what shape A? Shape ABOD is called a quadrilateral, a four-sided shape, and that always adds up to
180.
360. Yeah. So once we know this angle and this angle and this angle, we can quite easily work out that angle. Okay. So what is that going to be? So this is 90. This is 90, and BOD is equal to 130.
30.
Okay, 140. Hang on.
That's
Is this possible to be equal to 180? Sorry, 130. Sorry. Lovely. Okay, because these two here are already 180, and these two will add up to 180, so that will be 130. So we worked that out quite easily. So what's this angle here going to be now?
65.
65. But now we've got to go back and put in each step as an explanation. Okay, let's start doing that now. Okay. Now what do we say? We say angle ABO is equal to angle ADO. ADO is equal to 90 degrees. Now why is it equal to 90 degrees? Because the rule is okay, so the angle between a tangent, so we've made a statement, we're going to say why. The angle between a tangent and a radius is a right angle. I know my handwriting is a bit messy, folks, so please forgive me for that. But I am also saying it out as well, so you can. Okay? So that's the reason. So I've explained why these two are not. I've explained it. I've stated it and explained it now. That's what they want. Now, let's explain how this one was 130. What do we say next? Okay, ladies, do you have anything you want to say? Is there anything I've missed out something? One thing I've got to put in. So carry on. Okay, next part. We say it now. Okay. Angle BOD is equal to 130. And why is it equal to 130? So we say here angle sum of a quadrilateral. What quadrilateral? Quadrilateral ABOD is equal to 360. Therefore, 360 minus 90 minus, oops, that's supposed to be 90, minus 90 minus 90 minus 50 is equal to 130. So now we've explained that. Whoops. So we explain this, this, and this. One more bit to explain the actual answer. Let's change colors. You choose a different color. Okay. Now, angle. This angle here, what's it called? The one they want us to look at, what is it called? Angle BCD. Angle BCD. Angle BCD is equal to 65. Do you see here? I'm actually telling them the answer first. I'm saying this answer is this and then the reason. Okay, so when you do each bit, we state our statement. This angle is equal to this is equal to whatever, and the reason for that is this. You give the written after. So this is the style that you need to do for the examination. Is equal to 65. Why is it equal to 65? So the answer is the angle. Okay, which an arc subtends at the center of a circle is twice that which is subtended at the circumference. So we're saying here, this one is always double of that one. That's what we're saying. That's why it's 65. We're working out here. So 130 divided by 2 is equal to 65. And that's the end of that question. Let me just quickly pause this video. And okay, back to live recording. Question number 22. The table gives some information about the speeds in kilometers per hour of 100 cars. Okay, got speed, frequency. On the grid, draw a, what's the keyword here?
Histogram.
So histogram is normally, we have bars, like rectangles, but they are normally different lengths. There can be different lengths, yeah? And obviously the height will always be different normally. Now, who remembers the formula for frequency density?
Frequency.
Density is equal to frequency divided by class width. Now, this here is called the class. Class of data is from where it starts to where it ends. Now, I'm going to put a little mini insertion here. Class width. So, the width of 60 to 65 is? What's the width? 5. From 65 to 70, the width is? Class width is? 5. 70 to 80, now the width is? 10 is changed. 80 to 100 is changed again. 20. So if I put down here frequency density, now frequency density is equal to the frequency divided by the class width. So this number divided by that number. So I'm just going to change color now. Not me personally change color, but the color of my pen. 15 divided by this number here. That's right in front here. 15 divided by 5 is equal to 3. So 25 divided by, oh, excuse me, oops. 15 divided by 5, 25 divided by 5 is? And 36 divided by this number here?
2.6.
Okay, and then 24 divided by?
1.2.
20 is equal to 1.2. Beautiful. Okay, I don't need to we need to do another column in there. Okay, are we happy with those values so far?
Yeah.
Now remember, when we have a frequency density, what goes up here? What goes down here? Along the bottom of our graph will be what? The speed. And along here will be what? Frequency, density. So this here will represent on the x-axis, and this here will be represented on the y-axis. We do not, folks, we do not ever plot the frequency on the frequency density graph. Here they haven't labeled the axis. You should know that. This y-axis is always going to be the frequency density, not the frequency. So don't plot the frequency, okay? You'll get the question wrong. So frequency density is the y-axis. Okay. I need to move the graph up. You know these numbers here. Can you give them back to me when I need them, please? So I can't do everything on. So if I move it up, I can't keep on. There we go. Right. They've already helped us with the bottom scale. Thank you very much, the examiner. Speed's given to us. Okay. This frequency density, I think that looks a little bit kind of tatty. I don't mean it in the other way, but let's write it properly. Frequency. You don't want to upset the examiner. Frequency density. Okay, now, so we need to go, what's the maximum value for frequency density? What was it? So 5.
Yeah.
Okay, let's start here. 1, 2, each big square, 3, can we fit it in? 4, let's just, sorry about that, folks, I've written on top of there. Apologies for, I didn't leave enough space there. So the 5 is here, 4 is here. Oh. 4 is here, 3 is here, 2 is here. It's a nice scale today. Okay, right. Can you give me the information, please? Can I look at your graph, please? I'll grab your paper. Thank you, Mr. Hamza. Okay, the first one is 60 to 65, and the height is 3. So let's change color. Let's go for the dark green, and let's get a square. So please, folks, please bear with me while I try my best to get this nice graph. Okay, I did ask for a different color. Okay, let's just change it. Okay, that's better. Okay, right. That's lovely. Are we happy with that? Is that right, folks? Okay, the next one is from 60, that's 60 to 65, by the way. The next one is 65 to 70, and that has a height of? Height of 5. Let's change color again. 5 is up here. Okay. Okay, now we've done 5 in that one. Let's change. Now, okay, the next one is from 70 to 80. That has a height of? What's the height this time?
3.6.
3.6, which is over here. And the next one is from 80 to 100, and that has a height of 1.2. Okay. Oh. Are we happy with that now? You got those 4 different colored bars. Okay. I'm not going to start shading them out, probably make a mess of it. But do we get that now? Yes. Happy with that one? Should we move on to the next question? Okay. Right. Let's make this little bit bigger. That's better. That's lovely. Okay, Mr. Hamza, you can have this back. Okay, simplify fully x squared plus 3x minus 4 over 2x squared minus 5x plus 3. Hey, go on. I've missed one. Okay, go on then. Oh, okay, sorry. I didn't see that question. Pardon me. Okay, folks, students have missed the question. Work out an estimate for the number of cars with a speed of more than 85 kilometers. Okay, let's go up a bit. Okay, let's zoom it back down a bit. Here we go. Now 85, let's get a different color now. Let's get it red. Where's 85? 85 is? Yeah. I make my screen a little bit bigger this way. Okay. Now, can you see the little red box? Okay. So that represents, let me get hold of a pen now. Give me a second, folks. Pen. Okay. This area, let me get it red. Okay. Did anybody signify a red box here? That's starting at 85. Speed more than 85 is everything in the red box. Now, estimate for the number of cars. Number of cars is the same as saying they want to know the frequency, how many. To work out the frequency and the frequency density, what do we work out? We got to work out the area of that red block now. Now, how do we work out the area? Area is equal to length times by width. The length is from 85 to 100. What's that? 85 to 100 is what? What's the length? From 85 to 100, what is it? What's 100 take away 85? 15. So the length is 15. And then we've got to work out about the width. What's the width? 1.2. So we got 15 times by 1.2. Can somebody give me a solution to that, please?
18.
So work out an estimate for the number of cars with a speed of more than 85 kilometers an hour. The answer is approximately, actually in this one it looks like exactly 18 cars. That's how you would do that kind of question. You have to interpret the area. The area in a histogram represents frequency. Okay, thank you for reminding me, Mr. Harun. Let's move forward. Whoops. Okay, make it bigger. Right. Mr. Hamza, do we need help on this next question now? Yes? Yeah. Huh? Not yet. Simplify fully x squared plus 3x minus. For this important question, you need to see this one. Simplify fully. Okay. Now, what we need to do for this, we need to factorize the top, factorize the bottom, and then start to cancel. Okay, we have x squared plus 3x minus 4. Now, we're looking for two numbers that multiply to give you minus 4. So minus 1 times by 4 plus 1 times by minus 4 minus 2 times by plus 2. Okay, and then when you add them up, it's going to give me a value of 3 plus 3. So it's going to be the, happy with that one? So we say x minus 1 and x plus 4. Okay. Rutaba, did we get that? That one for the top?
Yeah.
Good. Let's do the bottom one now. So 2x squared. So that was split up as 2x and x. That's the only way you can split that up. So we're still looking for the numbers that multiply to give us 3. So 1 times by 3 minus 1 times by minus 3. Okay. Now, in this type of question, where you put the numbers does matter. Whether you put the numbers in the first bracket or the second bracket. So, what should we put opposite the 2x? The minus 1 or the minus 3? Folks, what do you put out? Okay. So, we're looking for the numbers that multiply give you 3. 1 and 3 and minus 1 and minus 3. Okay. So, I've already put a little dash there as well as that. Now, what do we put? What are the numbers that we're going to use? Are we use minus 1 and minus 3?
Yeah.
That one. Good. Because minus 1 times by minus 3 gives us plus 3, which we need. And when you add them up, it will give you negative. These numbers don't add up to minus 5, does it? That doesn't work for this question because we have a 2 in the question. So it works slightly different. So let's think Where is the best place to put these numbers? X squared plus 4x minus x is okay. Come on.
Yes, here minus 1.
Minus 3 here.
Yeah.
And okay, that'll give you 2x squared minus 2x minus 3x, bang on minus 1. We got a minus 1. Right, that's lovely. Okay. Now what can we do? We can cancel this one with, and that was the whole point of doing this exercise. So that leaves you with x plus 4 on the top and 2x minus 3 on the bottom. And now you can remove the brackets if you want to. So put the answer, just copy the answer back down over here. And that is finished. Okay, write this as a single fraction in its simplest form. Okay, let's start off the question. So, anybody got ideas on how do we approach this type of question? Rakaba, any ideas on what we do? We need to make the fractions, what's the key word? Yeah, we need to make them equivalent. Okay? X plus 2x minus 2, we need to make the fractions on the bottom the same. So, we multiply this top and bottom by the other denominator, okay, which is what? X minus 2. So we multiply each fraction by the other fraction's denominator. So this fraction here, this fraction here gets multiplied by this, and this fraction is multiplied by that. So x minus 2, what do I multiply by top and bottom? By x plus 2. Oh, I don't want to do that. Oops. Lovely. Okay, now what do we have now on the top? On the top we now have 4x minus 8 on the first side plus 3x plus 6, yeah? Over x plus 2. I'm not multiplying at the bottom, by the way. We're not multiplying at the bottom. We're just leaving them exactly as it is, as a product. Just adding some brackets to make it look more neater. X plus 2, yeah, that's the same thing. Now, once the denominator is the same, what can we do with the top? We can now add the top. Beautiful. Lovely. So we have 4x minus 8, add 3x plus 6 over a common denominator, which is x plus 2, x minus 2. Don't forget, this here is the same as this, even though it's written back to front, because in mathematics the order doesn't matter. Okay, are we happy with that? So what do we get on the top when you simplify the top? Any more for any more? 4x minus 8 plus 3x plus 6. What do we get?
7x minus 2.
7x minus
2.
And what do we have on the bottom?
The same as the top.
X plus 2, x minus 2. Can that be written any more simpler?
Yes.
Go on then.
X squared minus 4, 2, 4. I don't know.
Okay.
Something to the square.
Okay, what is it? X squared minus 2 squared, isn't it? We can't read like that. This is called the difference of 2 squares. Because look here, x plus 2, x minus 2. When you multiply that, all you get is x squared minus 4, isn't it? Yeah? So we got that 7x minus 2 over x squared minus, well, that would be written as, what's 2 squared? Can be written as
4.
4. So let's go to that and make it into 4. Done. That goes here. Are we happy with that? I think we got one more question left now. No, actually we got 2 more questions left. Okay, express the recurring decimal 0.281 as a fraction in its simplest form. So what do we say? We say let x equal 0.281. So which part is recurring, by the way? All of it?
81.
Just 81. So 81 and then 81. I understand. Let me just actually get rid of that for the moment. Just give me a second. I want to just do it over here now. You'll see what I mean. 0.281818181. Now, what do we do next? After we've done x is equal to that, what do we do now? We change. Now we've got to work out. Now we need to make sure that the decimal numbers line up in such a way that when we take it away, it makes sense. Yeah, it gets rid of all the decimal part. So what happens if we had 10x? What would we have? 2.8181818, for example. Now what would happen if we were now to multiply x by 100? The number, this first number would become what? 28 point, was it 181818181. Now, at the moment, are these numbers lining up? They're not going to. Can we eliminate the decimal part at the moment? The answer is no, they're not lining up. Should we do now the next one? Should we do 1000x? What's 1000x? Give us 281 point. What's after 281? 8. Come on, come on. 818181. Now it lines up with something. What does it line up with? Second one, isn't it? Okay. So this one here, look here, look. All of this lines up with all of that. And that's what we need. We need the decimal part to line up so when we minus them, it comes down to 0. The decimal part gets eliminated. So we are interested in 10x and 1000x. So let's do this one minus that one. 1000x minus 10x will give us, what's 1000x minus 10x, honey? 990x. Okay, now what's 281.81 blah 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 minus 2.81 blah 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 blah. Now what we know in this part of the calculation, this part, whoa, I don't want to do that. Okay, this part of the calculation gets eliminated because when you minus them, they're both the same. So we're now dealing with 281 minus 2. What is 281 minus 2? 279. Don't feel shy to say the answer. Now we can quite now easily happily work out x. Opposite time by 990 is divided by 990. Okay, now we need to cancel it down. Folks, any suggestions, Baba? Any suggestions on what we can cancel it down by? Top and bottom. We can divide top and bottom by? Should we do 3 first?
Yeah.
Okay, that color is too light. I can't see anything. Okay, let's delete that. Divide top and bottom by 3. What do we get with Baba when you do that?
93 over 330.
330. Can we cancel it again?
Yeah, by 3.
What do we get now?
31 over 110. And then can't do anymore.
You sure?
Yeah.
Yeah. 31 over 110. And so that is that our final answer?
Yeah.
Okay. Good. Okay. So we are now on the. Okay, I think we got quite a bit left now. We got this. Okay. We got this one and the last one. Let's have a break now. 5. Okay, question number 25. The diagram shows a solid metal cylinder. So we have the volume of a cylinder here. Metal cylinder. The cylinder has a base radius 2x, so that's the radius. The cylinder is melted down and made into a sphere of radius r. The height is 9x. Find an expression for r in terms of x. So they're talking about melting it down. So they melted down, they're talking about volume. So the volume of the cylinder must be equal to the volume of the sphere. So it's a volume of cylinder equals volume of sphere. So that's the ball. Okay, that's a cylinder which is here like a drinks can. That's like a football, yeah? Sphere. So let's start putting in some values. So the volume of the cylinder is equal to pi time by the radius squared. What is the radius by the moment? What is it?
2x.
So the radius squared, so it'll be 2x squared time by the height. The height is what? What's the height? Height is 9x. Now the volume of the sphere, okay, you can change. What is this? 4/3. It's up here. Okay. Time by pi, time by the radius cubed. It says there, the cylinder is melted down and made into a sphere of radius r. So the radius of the sphere is no longer 2x, it is just r. So it's time by the radius cubed. Now it wants us to find an expression for r. What that means, they want you to make r the subject. So rather than all of this, you need to have something that says, when you finish, r equals. That's the answer. R equals. We need to get rid of all this extra stuff. So let's do some cancelling. So if I divide this by pi, I can divide that by pi. Now we have 2x squared, that becomes, what's 2x squared?
4x.
Squared times by 9x. That will give you what? What's 4 times by 9? 36.
36.
What's x squared times by x?
X.
X cubed. Okay, on this side here we have 4/3 times by r cubed. Now, opposite of dividing by 3, oops, I didn't want to do that,
Times.
is times. And opposite of timesing by 4 is divide. So now we're going to have to move them over. So put a time by 3 here and a divide by 4 here. Are we happy with that so far? So the divide by 3 comes up here on the left hand side, and the time by 4 comes down here. And the intention is to get r cubed on its own for the moment. And that's been cancelled and that's moved. Are we happy with that so far? Now, what is 36 divided by 4? If you start cancelling that down.
9.
So divide that by 4 is 1. Divide that by 4 is 9. What's 3 times by 9?
27.
Now, we need to work out r, not r cubed. So what do we do with the cubed? We take the cube over from here, come to this side, becomes a cube root. So if we say 27x cubed cube rooted, that gives you r. What's the cube root of 27? And what's the cube root of x cubed?
X.
And that's finished. The question is done.
What about cube? You've not got cube.
That there.
Cube. 3x cubed equals r cubed. Oh no.
That's it now, yeah?
I got it.
So we cube root the 27 and we cube root x cubed, that finished. So r is equal to 3x or 3x is equal to r. Done. Okay, we're going to make it a little bit smaller so we can see it. Okay, the graph of y equals f of x is shown on each of the grids. That's function of x, which looks like a quadratic function, which is. On this grid, sketch the graph of y is equal to f of x minus 3. And what do we say in our lessons? When we put a minus in here, you would assume the minus means move to the left. But actually, we're moving it in the opposite direction. Is we're moving the whole function to the right by 3. So we're going to, if this minus 3 inside here, it causes a translation. Translation of plus 3 in this direction. So we get the whole graph. Now, don't forget, I've told you before, it's quite difficult for me to do the curves on my little writing tablet. So you're going to have to, let me just help you to kind of understand where we put the points. The easiest point is 1. So 1 minus 1, you move it from here to, from 1 to 1 add 3 is 4. So 2 add 3 is 5. And 0 add 3 is 3. So I'm replotting these points here. Okay. Whoa. Okay, I think I'm just going to take the plotting the points. Now, this one here goes 3 across. So we got 1, 2, 3. This point goes 3 across. 1, 2, 3. This one goes 3 across, that goes there. This one goes 3 across, so that goes there. This one goes 3 across, that goes there. And that goes there. Now, this point here, done. That point, okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And 1, 2, 3. And 1, 2, 3. So if you join up those all the red dots, you'll get the same curve across. I'm going to try my best to join them up. I'm most likely going to make a big mess of it because I still haven't got it. So I'm trying to do that as best I can. Slightly off, but that's it. So you have to go to that, minus all the wobbly bits. Okay, we got that? Are you happy with that? Here comes the last part of the question. Okay, here we go. This question says here, y is equal to 2. What happens when we put the 2 in front of the function? What are we doing to the function? Stretching in which direction? Like this, yes. So what happens to the 1 minus 1 it goes to? It goes to 1 minus 2. Okay. What happens with the 0 points? What happens when you double a 0? Stay the same. So these points here are fixed. They do not move. So now everything else gets further in. So this point here, which was here, will now be there. This point here, which is at 3, will now be here. Similarly, on the other side. That's here. This point here will be here. So we get a nice sharp, so that it'll be more kind of pulled up. Can we see that first? I'll put some extra points in so you can join them up yourself. Because when I start joining them up, it's going to look crazy. So I'm doing these points to help you to see how the graph should look like if you do the dot to dot. Obviously, you have to join the dot to dots up. Okay, so your graph will now look like that if you put the 2 on the outside. Okay, remember mine's the dots, yours will be a nice smooth curve through those dots. I will again try to join them up. Okay, no, I didn't want to do that. Okay. Okay, that's the best I can do it. Are you happy with that? Okay, that's the end of the paper. Okay,